In this video, we'll cover how to represent solution sets for compound inequalities. For each, we'll draw a graph representing the solution set, and then write it in both interval notation and set builder notation. For this first example, we're given the inequality, which is -3 less than x less than 1. One note here is that a longer way of writing this would be to state that x is greater than -3 and that x is less than 1. So looking at our number line, we have -3 less than x less than 1, and that puts x between -3 and 1, but doesn't include either -3 or 1. So I'm going to mark off -3 and 1, and then draw a line between these. So I want all values between -3 and 1. I don't want -3 or 1 though, so I'll draw this on this number line with open brackets, showing that this will go right up to -3 but not include it. And that open bracket is going to face inward toward the 1 when I put it on -3, and then similarly on 1 I'll put another open bracket also facing inward, so it's going to curve towards that other value of -3. So I've drawn that graph representing all values of x between -3 and 1. Now let's write it in interval notation. As an interval, and I'm going to shorthand interval notation here, I need values between -3 and 1. I can use this graph. I see those open brackets on -3 and 1. I'm going to have the same thing in my interval. However, I'm just going to have brackets, numbers, and a comma separating them here. So I'll put that rounded open bracket with a -3, comma, and then I'll put the 1 with another rounded open bracket. Now to write this in set builder notation, for a compound inequality like this, all that we do is make a set that says the set of x such that, and then we'll include that inequality, -3 less than x less than 1. So again, when we write the set of x such that, we write a curly brace x, that straight bar, then -3 less than x less than 1, and end it with a curly brace. Our next example is similar, except we have less than or equal to signs. So we have -2 less than or equal to x less than or equal to 3. To draw a graph of this on a number line, let's mark off where -2 is and where 3 is. And so this is saying that x is every value between -2 and 3. So I'm going to graph that. I'll draw my line there between -2 and 3, but it now includes both -2 and 3. And so to graph this on a number line, I'll put square braces on, and the square braces are going to face inward. So I'll have a square brace on -2 pointing inward and a square brace on 3 pointing inward. I like to think of the including as I put that line straight through that number -2 and straight through that number 3 to include them. To write this as an interval, using interval notation, I can use that graph that I just drew. So I need all values between -2 and 3. And again, this is a shorthand notation that's just going to use braces, numbers, and separate the numbers with a comma. So I'll have a square brace, -2, comma, 3, and then another square brace. For set builder notation, I'm again going to write the set of x such that -2 is less than or equal to x, which is less than or equal to 3, and then end it with my set brace. So I'll have this set, I'll write a set brace, x, for such that I'll put a straight bar, and now we'll do -2 less than or equal to x, less than or equal to 3, and I'll end that with that set brace, which is a curly brace. The next example we have shows -1 less than x less than or equal to 4. So I'm going to mark off both -1 and 4 on this number line. And because I have -1 strictly less than x, I'm not going to include the number -1. So I'll put a rounded brace, that rounded bracket on -1 pointing inward. I'll draw a line for all numbers up to 4. And then at 4, I'm going to put a square brace to include the number 4. And again, that will face inward. Now, to write this in interval notation, I can use that graph that I just drew. And I'll take -1, comma 4, and I'll need a rounded brace on -1 to show that I'm not including the number -1, and a square brace on 4 to show that I am including 4. For set builder notation, I will take the set of x such that -1 is less than x is less than or equal to 4. And again, I have curly braces on each side there, and the such that sign is written with that straight bar. These last two that we have involve or statements. So these are going to be a little bit different. So for this first one, I need values of x that are less than -2 or values of x that are greater than 1. And this is written x less than -2 or x greater than 1. So I'm going to go onto my graph and look at where -2 is. And for values of x less than -2, I can use the fact that this less than is pointing to the left and realize that less than -2, I'm going to go from -2 to the left, and I'm going to put an arrow to show that it continues on. Because it's strictly less than -2, I'm going to put a rounded bracket there, and it's going to face to the left. So this first part I've written shows values of x less than -2. I have this or, and now I need values of x greater than 1. So again, greater than 1, it's pointing to the right. I'm going to go to the value of 1, and then I'll have a line that points to the right, put an arrow on it to show it continues on. And at 1, I again need a rounded brace, and I will have that pointing to the right. So the second part shows x greater than 1. So both of these together are my set. So using interval notation, these are going to be two separate intervals that I then need to join to show the set. So for the first one, x less than -2, that part can be written with an open bracket, -infinity, comma, -2, and then an open bracket again. X greater than 1 can be written as open bracket, 1 comma infinity, and then of course an open bracket on infinity. And then I put a special symbol in between these to join them into a single set. So these are two separate intervals. I'm going to use what's called the union sign to join them into a single set. And that sign that I just wrote, it looks like a U but does not have the little tail on a U. So that symbol is the union symbol. Okay, so that's interval notation for x less than -2 or x greater than 1. To write this in set builder notation, this will be very similar to the other ones. I'm going to take the set of x, write my such that sign, and then in here I will simply write x less than -2 or x greater than 1. There's no way that I can combine this into anything smaller, so I simply put that statement including or in there. All right, for our last one, we have -3 less than x less than -1 or x greater than 2. So for this one, we'll go to -3 and -1, and we want all values in between there. So I'll draw a line in between there, and then I'm going to put open braces on both -3 and -1. Now for the second part, I'll go to where x is 2, and I need all values of x greater than 2. So I'll go from 2, I'll draw a line going to the right with an arrow, and then to show that I'm not including 2, but just going right up to the value of 2, I'm going to put that open bracket on 2, and of course it opens to the right. To write this in interval notation, again, I will need the union sign. So for -3 to -1, I'll write an open brace, -3, comma, -1 with another open brace. And for values greater than 2, I'm going to write open brace 2, comma, infinity. And then to join these into a single set, I'll use that union sign. So I have an open brace, -3, comma, -1, another open brace, the union sign, and open brace 2, comma, infinity. As our last part here, writing this in set builder notation, we'll take that inequality and put it into a set. So we'll have the set of x such that -3 is less than x is less than -1, or x is greater than 2, and end it with a set brace.